Hey guys, what's up? It's Eric with Advanced Level Automotive. Welcome back to the channel. Welcome back to another quick case study. Today, I'm back here at this car lot. I'm taking a look at this 2002, it's a Chevrolet Tahoe with a V8 5.3 liter engine. And the issue that they were having with this truck is that originally they had the brake light, ABS light on, and the traction light on. And so they did their own diagnosis and they found out that there was a problem inside of the ABS module, which is not uncommon. If you guys didn't know, it's real common for these trucks to have issues where the solder joints inside of the ABS module will actually crack, fracture, and that has a lot to do with the fact that the module is mounted underneath the vehicle. It's bolted to the frame. After years of vibration and bouncing around, the solder joints inside of the circuit board just start to come apart. So anyway, they decided to take the module apart. They resoldered some joints inside of the module and they put it back into the vehicle. And what they're telling me is that it actually worked for about a week. They didn't have any more lights, no trouble codes. About a week into it, all of a sudden the light came back on, ABS, traction light. And so they went back down there, opened up the module. Let me show you what they found. All right guys, so this is the original ABS module that came out of the vehicle. Like I said, they attempted to solder the joints inside of the circuit board. And so they had it in the vehicle for about a week and it worked. But about a week later, all of the lights came back on, so they went back underneath the truck. They took this apart, decided to open it back up, and let me show you what they found. Yeah, so take a look at that. You can see that this circuit board is completely fried. Now, when I say fried, I mean like half of it is missing. You can see that this had some type of short circuit internal to the board. Now, more than likely what happened was they probably tried to solder some of these joints in here and they probably used a little bit too much solder, which caused a short circuit. You know, oftentimes whenever you go in there to repair these, you really don't need to use a lot of solder, and oftentimes you don't need to add any solder to it. Sometimes you can just put a little bit of flux paste on there and then just hit it with the solder tip and it'll resolder itself back together. But yeah, this here is what happens when you add too much solder to the circuit board when you go in there to repair this. So they went ahead and installed another unit onto the vehicle. They found a used one at a salvage yard, installed it, and so now let me show you where we're at. If you take a look at the instrument cluster, you can see that we don't have any warning lights. So I don't see an ABS light, no traction light, no brake light. But if you take a look over here to the side where this traction button is, you can see that the traction off light is on, and no matter what you do, if you hit this button, you can't get this light to go away. So obviously there's a problem with the traction control system on this thing. And so let me take you guys over to the scan tool and show you what I found. So we're going to go in here into system selection. This one does have throttle actuated control, under 1,500 pound gross vehicle weight. Okay, so we have a list of all of the modules on the vehicle. First of all, we can go down here to the ABS module and I can show you that we can read fault codes, and what we're going to find is that we don't have any fault codes stored in the ABS module itself. So take a look here. You can see it says no trouble code, system normal. So at this point, the ABS module itself is not showing us any issues. So if we come back over here, let's go into the powertrain control module, powertrain system right up here. We're going to read fault codes, go to DTC information. And here we have two different fault codes stored. Starting at the top, we have this P1571 traction control torque request circuit. And then we have this P1689 traction control delivered torque output circuit. Now, a cool thing we can do with this tool, whenever you have it connected to the internet, we can actually do a code search. So I'm going to click on this P1571 and I'm going to search the internet for it. You can see it's going to Google our P1571. And we have some choices here. We can start at the top. And we'll see if we can get a code description for this thing. Let this page load up here. All right, so taking a look at this P1571 traction control desired torque out of range. Look down here, you can see the possible causes. For one, it tells us that we could have a faulty EBCM or electronic brake control module, or we could have a faulty PCM, powertrain control module. It says that we could have a problem in the EBCM where there's a harness open or shorted. Also, we could have poor electrical connection. So those are some of the possible causes. But really, I want to get into the meat and potatoes of this code. I want to know what this code is about, how the system works. Take a look here. So we have this code meaning. It says, what is P1571? It says the electronic brake control module, or EBCM, and the powertrain control module, PCM, simultaneously control the traction control. So the EBCM sends a requested torque message via a pulse width modulated signal to the PCM. The duty cycle of the signal is used to determine how much engine torque the EBCM is requesting to the PCM to deliver. Normal values are between 10 and 90% duty cycle. The signal should be at 90% when the traction control is not active and at lower values during traction control activations. The PCM supplies the pull-up voltage that the EBCM switches to ground to create the signal. So that is some really important information for us, and it helps us to understand how the system works. Essentially, the electronic brake control module is going to request a torque message signal to the PCM, and depending on the duty cycle of that signal, that's how the PCM knows how much torque to deliver. Then it tells us that at 90%, the traction control is not active, and at lower values is when it's activated. So like I said, really useful information to help us understand the system. Now let me take you guys over to this wiring diagram. Now if we take a look at the wiring diagram, you can see up here this dotted line. This box is going to be our EBCM, our electronic brake control module, and this box down here is going to be our PCM, our powertrain control module. And if you take a look at the pins here at the PCM and at the EBCM, you can see this right here is our requested torque signal. This is our connection between the PCM and the EBCM, where the EBCM is going to send a signal to the PCM requesting a certain amount of torque. Then if you look at this pin over here, you can see the delivered torque signal. This is where the PCM is going to respond back to the EBCM with the delivered torque signal. So obviously we have some type of communication problem here between the EBCM and the PCM. Now, as to why we only have codes in the PCM and no codes in the ABS module or the EBCM, I believe that has something to do with the fact that when I first got here, the battery in the vehicle was actually dead. So let me take you guys over here. You can see the jump pack. I had to connect the jump pack to the battery in order to get this thing to start because this battery was completely dead. So at this point, the truck has not been driven. It's been parked here. So I believe that's why we don't have any codes in the ABS module. Maybe this thing just has to be driven in order for it to set any other codes that might come up. But I think at this point, we pretty much know where to focus our energy on. We need to check to see whether or not our signal from our EBCM is reaching the PCM and whether or not our PCM signal is reaching the EBCM. And so there's a couple different ways we can go about doing this. We could go underneath the vehicle and check it at the connector right at the ABS module, or we could go under the hood and check it at the PCM or the powertrain control module, which is located right down here. And so really there's no wrong way of doing it. I think for my case, I really want to focus more on the ABS module. So what we're going to do is we're going to go ahead and probably put this up on a lift, see if I can get underneath, back probe the connector, and check our duty cycle. All right, guys, so we've got the truck up on the lift. Let me take you underneath and show you where the ABS module is located, or the EBCM. Right over here. Again, like I said, they recently replaced it. So this is a junkyard unit. But if you take a look here, you can see our two connectors. This here is a 2-pin connector for the power to the pump, the power in the ground for the pump. But the connector we're going to focus on is this other connector right here. And so you can see it's got this kind of clam shell over it. We're going to have to remove this shell so that we can gain access to the wires and we can back probe it. So being kind of tight here, I might have to just kind of disconnect this one here, move it out of the way. Okay, yeah, so we'll move that out of the way. Like I said, that's for the power and ground for the pump itself. So just kind of move that aside. Now we can gain access to the connector we're looking for. All right, so I'm going to pop this little red lock down, just using the tip of my test light, so that we can unlock this connector here like that, and then we'll squeeze this and disconnect it. I'll take a look at that. Our connector is actually damaged. All right, guys, so I don't know if you noticed, but when I disconnected this, some pieces fell out. And if you take a look at the face of this connector here, you can see the part of the plastic is actually crumbled and falling apart. So you see some pieces falling off there. Yeah, this connector has definitely got some damage to it. Now, whether or not that's our issue, I'm not really sure, because the pins inside actually look like they're still where they need to be. None of them seem like they're out of place. Anyways, if we take a look inside of the connector, you can see our pins in there. Let me focus in a little bit right there. None of them look bent. There's no corrosion in there or anything. So again, I'm not really sure if that's where our problem is. But let me go ahead and continue with removing this clamshell. There's a clip right here. Pop this open, and there we have it. You can see we can split this in two. Yeah, I think we got to remove this red lock completely. I got it right here. I'm going to set this aside, and we can spread these open and gain access to the back of the connector. This way we can back probe it while it's installed. So just to remind you guys what it is we're looking for, again, we're down at the EBCM, which is the electronic brake control module, and we're looking for these two pins, A4 and B4. So A4 is going to be a tan and black wire, and B4 is going to be the orange and black wire. A4 is a delivered torque signal, and B4 is a requested torque signal. So let's move underneath and see if we can find this orange and black wire and tan and black wire. All right, so moving over to the connector, I believe I have located our wires or our pins. So if we take a look here, you can see this top row right here. I don't know if you can read it, but it says B1 right there. So this yellow and black wire, that's our B1. So if we count 4 over, you can see that the 4th one over is this orange and black wire right here. So this is going to be our B4 pin. And then on the opposite side, we have row A. So let me turn this around, see if you guys can see right here. It is labeled A1 right there. So A1 is going to be this brown wire. If we count 4 over, 1, 2, 3, 4, you can see right there, that is our tan and black wire. So they're right across from each other. You can see the orange wire right there and the tan wire. So we're going to install back probes on both of these. Then we're going to reconnect the connector, hook up our lab scope, and check for a duty cycle signal. All right guys, so let me show you my setup over here. Hanging from the frame, I have my lab scope, and we have it just on a graphing mode. And so up here, you can see that I have my 2 back probes installed into the back of the connector. This green one right here is going to be connected to the orange and black wire. That is our B4 pin, which is our EBCM request signal, the request that goes to the PCM. And then on this blue wire, you can see I have it back probed to the A4 pin, which is the tan and black wire, which is a signal coming back from the PCM to the EBCM module. So at this point, I think what I want to do first, because I still have this disconnected, again, with this disconnected, we should be able to see the steady voltage that the PCM sends to the ABS module or the EBCM. Because if you guys remember on the description, it did tell us that the PCM provides the pull down voltage for this EBCM on this circuit. So the PCM sends the voltage, and the EBCM brings that voltage to ground to create the duty cycle signal. So with this disconnected, if I connect this lead, which is this green wire, to my lab scope on my yellow lead here, which is my channel 1. All right, sorry about that. I had to change my position so that we didn't have so much glare from the sun. Anyway, here I have the green lead, which is connected to the orange and black wire. And this is my lead for the lab scope. So I'm going to connect it. We're going to see if we have our voltage from our PCM. Take a look there. You can see on the graph, we have a steady 5 volts. So what this means is that the PCM provides 5 volts, and it's the EBCM's job to drop this 5 volts down to ground to create a duty cycle signal. So right off the bat, what this tells us is that more than likely the PCM is good, at least on this circuit. We haven't checked the other circuit. So I'm curious if the other wire, so I'm gonna go ahead and disconnect this. I'm curious if the other wire, which is our blue lead, let me grab it. Okay, so I've got the blue lead here. Again, this blue lead is attached to the tan and black wire, and I have my lead for my lab scope here. Now, I'm just curious as to what I'm going to see whenever I connect this wire, because we know, according to the information, that the PCM sends the power to the EBCM on the orange and black wire, but I don't believe that's how it works on the tan and black wire. If I'm not mistaken, maybe the tan and black wire works the opposite, in which the EBCM is going to send the power to the PCM. So again, here we have our lead for the tan and black wire. I'm going to connect it to the lead for my lab scope and take a look at the lab scope. We have nothing. Let me disconnect it. Yeah, you can see that we have very little change on the graph here. So this is showing us here that more than likely it is the job of the EBCM to send the 12 volts to the PCM on the tan and black wire. So now I'm going to carefully reconnect this connector. We're going to check our values while this thing is connected. And again, guys, because this connector is a little damaged, I'm having to be really extra careful with this. Let me kind of line it up properly before I decide to just shove it in there. There we go. And we are installed. One thing I would like to mention is, yes, I did have to go ahead and cut one end or one side of this little clamshell off, but it's no big deal. We can reinstall it, and again, it clips on the edges. Sorry, I just dropped it. But anyway, in order for me to reinstall it and fit my back probe into this back area right here, I had to just kind of cut that piece off. All right, guys, so moving back over to the lab scope. Again, we are still connected on our, well, I just disconnected it. Let me reconnect it. So we were still connected on the tan and black wire. And so again, you can see that there really was no difference between us having the connector connected and disconnected on this wire here, because we see no change. We still don't see any voltage. What we were hoping to see, or at least what I was hoping to see, was that on this tan and black wire, we were going to have a steady voltage being provided to the PCM. I just don't see that right now. So let's see what happens when we connect the orange and black wire, which is our green lead here. So I'm going to connect it. Take a look at that. We have our steady 5 volts there still, but the interesting thing is that we don't have a duty cycle signal. Now, I don't know if it matters, but just in case, I'm going to reconnect this power and ground for the ABS motor or the pump. Maybe it may make a difference. Just according to the wiring diagram, it didn't look like this fed anything internal to the circuit board. So let me try to reconnect this here. Kind of a tight spot. You know what? I really think that this wiring harness for this connector is supposed to go behind the other one. So let me pull this back out so I can snake this in from the back side, connect it, and then reconnect this other connector. Okay, so I've got both connectors connected. Again, this connector here for the power and the ground for the pump, and then our connector here, which has our 2 wires. So let's move back over to the lab scope and see if it made a difference. Okay, so back over at the lab scope. Again, at this point, we're still connected to our orange and black wire. And you can see that we still have our 5 volts coming from the PCM reaching the EBCM, but the EBCM is not bringing this down to ground. It is not creating a duty cycle signal. Remember, guys, according to the code description, even with the traction control system off, we should still be seeing a 90% duty cycle signal on this graph here. So this is looking more and more like we have a bad EBCM. All right, guys, so at this point, I feel pretty confident saying that we probably have an issue inside of the ABS module. Again, due to the fact that we have our 5 volt reference or voltage coming from the PCM, and it is reaching the module itself. And so that in of itself tells us that the wiring between this point and the PCM is good, but the module itself is not bringing that signal down to ground. Now, the other thing I would like to mention, of course, is that connector. Like I said, it does look like it has some cracks on there, but I already double checked it, and the pins inside are still intact. They're still in place, and none of the pins are bent inside of the actual module connector itself. So I don't think we have a problem there. The other reason is that on the scan tool, if I take you guys over here to the scan tool, let me show you. We actually have full communication with the ABS module. So I can extract fault codes, and then of course we can look at live data here. So take a look at all of the live data we have inside of the ABS module. Now, if we had some type of problem where we weren't getting a power feed or a ground to the ABS module itself, you know, we wouldn't be able to communicate with it like this. We wouldn't be able to see all of these data PIDs. Now, I did take a look through the list of data PIDs, and there's nothing that actually refers to the torque request signal or the torque feedback signal. So I was hoping that there was some kind of data PID that referred to that or showed us something inside of the system. But really, there's nothing pertaining to our specific issue that we have with this module. So it seems to me that whatever's happening inside of our ABS module here, or the EBCM, is specific to the torque request signal circuit. And so at this point, I'm gonna go ahead and talk to the owner. We're gonna find out whether or not he wants to replace it with another used one, or go ahead and replace it with a new one. Now, if you guys didn't know, a new unit or EBCM for this thing is not cheap. They're usually somewhere between $500 to $600 for a new unit. So, you know, it makes sense with vehicles like this being this old to just buy a used one. But this is such a common failure item that buying a used one is always kind of a toss-up. You know, you never know if you're going to get a good one or not. So the other option we could do is try to repair the one that's on the vehicle right now. So whatever is happening with this one, we could try to open it up. Maybe we can find something inside of the board that needs to be resoldered. So that is an option. At this point, like I said, I'm going to go ahead and talk to them. I'll keep you guys posted. All right, guys, so I believe I have found the problem. Now, I talked to the owner, and he wanted me to go ahead and try to repair the unit. So the mechanic went ahead and removed it for me. But, you know, honestly, I don't know how I didn't notice this before. But if you take a look inside of the connector here, so this is the one that the mechanic just pulled off of the car or the truck. So this is the one that we were testing. And if you take a look at the connector here, you can see, again, if you take a look at the bottom row where it says B1, so this row here is our B row, and the A1 up there, you can see that row is our A row. So if you count over 4 pins, again, we were looking at B4 and A4. So count 1, 2, 3, 4, our pin is missing. Same thing up at the top. Count 1, 2, 3, 4, our pin is completely missing. Now take a look at the original one that came off of the truck, the one that burned up, and you can see that all of our pins are there. None of them are missing. So what that tells us is that when they bought this one at the salvage yard, they bought a unit for a vehicle that did not have the traction control system. Now looking at this thing from the outside, I mean, it looks almost identical as the other one. You can see them side by side, but these two units are not the same. All right, guys, so in conclusion, it's pretty obvious what happened. The shop ordered the wrong part. The mechanic installed the part onto the truck without comparing it with the old one, which, you know, I really don't blame the mechanic for that because he was pretty much just doing what he was told to do. And quite honestly, I don't think I can blame the person who ordered the part. You know, maybe they did request the correct part from the salvage yard, but the salvage yard just sent whatever they had. I don't know where things went wrong. I'm not here to blame anybody, but you know, a lot of my questions were answered when I saw the connectors, or the difference between the two connectors on the old ABS module and on the one that they replaced it with. And so what we found with those 2 pins that were missing, when I saw that, all of the questions that I had were immediately answered. Going back to the very beginning, where when we looked at the truck, we saw that, you know, we didn't have an ABS light, we didn't have a brake light, all we had was a traction control light. And the other thing is, when we had the scan tool connected, we didn't find any codes or trouble codes stored in the ABS module. We found trouble codes stored in the PCM, which is the powertrain control module. The reason for that, again, was because the ABS module was never designed to monitor the traction control system, nor was it designed to send and receive signals from the PCM on those circuits. So that's why we only had codes in the PCM and no codes in the ABS module. That also answers another question that I had, was the reason we didn't see any data PIDs for the torque request signal or the torque delivery signal on the ABS module. Now, I'm not 100% sure about that. I would have to look at another vehicle that does have that system on the ABS module and see if there actually are data PIDs. But I'm assuming that if you have that system, you're going to see some data PIDs on the scan tool for it. Among many of the other questions that were answered, one of them was the reason why we didn't see a duty cycle signal whenever we were back probed on the orange and black wire at the ABS module connector. Again, what we saw was the 5 volts coming from the PCM, but we saw that the ABS module was not grounding that circuit. It was not creating a duty cycle signal. And likewise, on the other circuit with the tan and black wire, you know, in that case, it was kind of vice versa. I don't think that the PCM was supposed to be sending power. I'm pretty certain that the ABS module is supposed to send out a voltage to the PCM, and it's the PCM's job to ground that circuit and create a duty cycle signal for the feedback. But like we saw, there was no voltage there, nor was there a duty cycle signal. Anyways, guys, at this point, I'm gonna end off the video. Like I always say, I hope you found it useful, educational, informational, entertaining. If you did, make sure to give it a thumbs up. If you haven't done so already, make sure you subscribe to the channel, hit that notification bell. I'll see you guys in the next one. Thanks.